So there's a situation that arises sometimes where we can get the least substituted product or the least stable product as our major product. This is called the Anti-Zaitsev's product. Hofmann product are the Anti-Zaitsev's rule. This is going to use a large, big, bulky base. And kind of the go-to base that we use is T-butoxide. So T-butoxide is a CH3 group connected to a carbon, connected to an oxygen with a minus charge. But then on this carbon we have 3 CH3 groups. So that's a pretty classic big, I call them big, bulky bases. There's some other ones that creep in from time to time. So diisopropylamine, right? You have triethylamine, 2,6-dimethylpyridine, another one. There's other bases out there also, but these are the most common, and the T-butoxide is probably the most popular of the group of 4 here. So let's look at an example here. We'll go through here and draw this out. So I want to put a carbon atom here, and then another carbon here, and then our third carbon down here. Okay, and this last carbon I want to have just be a CH3. And then let's put a bromo group up here, and then we'll throw down here another CH2, CH3, and then let's put an H atom right there. Right, and then we'll go through here. Now, in the previous examples that we've seen, we've used hydroxide. So here we're going to use T-butoxide. And remember that's CH3. Sometimes you'll see it written that way. CH3. How many are there? There's 3. And then there's a carbon, an oxygen with a minus charge. And sometimes you'll see this as sodium T-butoxide or potassium or something like that, T-butoxide. So when you see the situation, you think to yourself, aha, here we have a big, bulky base. So in a big, bulky base, what happens is, remember, that base has to come over and it has to grab one of these H atoms, right? Now remember, that's on a wedge, so the H that's lost would be this H, right? Our interior, it would be that H. So these are the 2 beta positions we have. So it's really fairly straightforward. If you ask yourself this question, which one of these H's is easier to lose? The H at beta 1 or the H over here at beta 2? So here or here? Well, this base is a big thing, right? This has to come over and fit in right here. And there's just more happening. You've got this ethyl group, another ethyl group, and then this big group that's over here to deal with. So we say there's more steric interference at the beta 2 position, where this can come over here and just kind of, glance by and grab that. There's just less business. There's less sterics happening down at that end. So simply put, the H that's right here is easier to pull off because of sterics. So it's really just boils down to stuff being in the way. So T-butoxide is going to come around, grab that H. We're going to make a double bond there, and then we're going to kick off bromide here. Right. So as far as our products here, we're still going to get 2. Right. So one of our products is going to be this. So if we look at the elimination at that position, we're going to be doing this 1, 2, 3, 4, 5, right? And then that's going to be a double bond right here. And then if we want to just keep this out here as an ethyl, we could write it out here like that. It's not totally necessary because it's not a chiral center, right? But anyway, that would be one of our products. And then the other one would be this. So we would also get this product. Right, at that beta 2 position, we could lose an H, and it would give us that. And this doesn't have, we don't have to be concerned with cis or trans here because it doesn't apply. But looking at these two, let's make a couple comments. So this is the most stable. It's the most substituted. It is tri-substituted. This is the least stable, and it is mono-substituted. However, in this case, because our base is large, this turns out to be our major product. So often you'll be asked to draw the products of a reaction, and then there might be a follow-up question saying, well, of the products that are formed, which one would be the major product? And you have to look at your base as an indicator as to whether or not it's going to be the Zaitsevs or the anti-Zaitsevs rule, which one of those rules you're going to apply.